let me just give a couple Sarah announcements and then turn it over to Paul. Let's see. Well, welcome to Drake's Surrounds Australia. Um, you notice that little, I'm almost trying to get something there. Um, we just had the very successful Eastern Conference in Green Bank, Virginia. Had about 30 or so people in attendance, with another 30 or so online. Uh, Lots of great talks. Those talks are, I've got only a couple left to upload into the Sarah YouTube channel. So if you guys want to go pull those YouTube videos to hear what the speakers said, they're almost, I think, got two or three up. I should have most up tonight. We did get a great Green Bank uh, telescope tour. You go all the way to the top where the receivers are, the reflector, all the way down. It seems that it's down for the count this summer because the train wheels they've got on there, one of the train wheels uh, actually broke. One of the the edges that hold it onto the track, one of the edges just had a big chunk come out of it. It seems that the whole thing's 17 million pounds, and I'm sorry, 17 million pounds per train or per track on there. On top of that, they have these big concrete. The whole train track or that goes in a circle is on a piece of concrete, and that concrete's starting to crack. So they're fixing the whole foundation. Also, they're going to have to paint it. One of the trivia facts that the Green Bank director was asking us is how much do you think it costs to paint the largest moving structure in the world right now? And so we all came up with numbers, but it's $40 million to paint the Green Bank observatory or telescope. So it's just amazing how much that costs. The tour guide that gave it said that the original paint was not the right paint, and now they have to sandblast it and the whole thing, and that what they use is uh, painters that do bridges. So those guys they need to be able to rappel underneath the structure and walk along the frames and everything to get the painting done. So very interesting system they got there. Um, we did have a board meeting. Uh, Paul Butler is now a Sarah board member, so you guys have representation. We also have our other international is Dr. Wolfgang Herrmann, who's the in Germany in Osterpieler, and he's the first amateur to get an FRB, and I think he holds the current record for the most intense FRB ever recorded with their 25-meter telescope. And part of that is because Dr. Sander Weinreb, who is also online today, uh, gave him some specialized LNAs to put on the 25 meter, and now he's comparable to most of the professional telescopes. So we'll talk a little bit about that too. But congratulate Paul on being on the board now. And what a board member does, and Sarah, one is just constant advice. I go for them all the time for advice. They're very experienced people in their own right, and then they look at the journal. They sort of proofread the journal. So we have what's close to a peer-reviewed journal, but not officially, because we got a lot of internal amateur experts looking at the journal before it goes out. Let's see. The other new initiative being done by the organization uh, is meteor beacons. All right. The currently when the in the U.S. when the just a minute, let me get my When the analog channels went away to shift to digital, we lost the ability to do the reflecting for the meteors when the meteors come down. And normally they hit that nice 50 megahertz channel, and then it bounced off the meteor trail, came down. We were able to detect the signal from that the ground station on the reflection, counted as a meteor. Well, the analog channels went away in the U.S. There's a couple in Canada and Mexico, but most anybody doesn't have that. So Sarah is going to take on the initiative to establish beacons across the U.S. that enable the entire U.S. to have a beacon for meteor detection. The first one's going to be sort of like a CW. If you key down a CW, then you should be able to get it. A beacon requires us every 10 minutes to put in our call sign, so that's relatively easy. The new initiative, once we get that working, the next step is to put GPS tones in there, which will enable precision ranging from that particular meteor detection. With that, we'll be able to start doing pointing or precision where the meteor came from. We combine that with a couple detection stations. We'll figure out the distance, the angle it came from, figure out which, from Perseids, whatever, which, what am I thinking of? Which asteroid passed? All of these meteor things come from different asteroids or comets passing in the past. We'll be able to figure out which one it came from and get some science with this. So anyway, so that's sort of the goal. If you want to get involved, in fact, the nice thing would be is if you guys set up one down there, you probably need a couple to get the Continental completed. You can use our design. They're still designing it, but we'll get on our listserv. They're actively discussing it right now on listserv, the design of it and how to locate it, etc. It'll be from wherever we put it, which will be at a ham radio station's location. The detection system can be within 100 to 1,000 miles of the beacon. It seems to be the range, the optimum range area. So it's theoretically we can cover 2,000 mile swaths, so we think three will cover the U.S. and then we'll start putting them other places. And I think Europe has a couple already. We're sort of modeling them out that. And I don't know if you guys have the same issue down at where you guys are at, that you don't have any beacons for the meteor detection. I don't know, Paul, is that a problem down there?
I was going to say, Rich, I know Andrew's doing the same as me, and we're using the amateur radio 6-meter beacons, which work very well because there's enough of those around. I think we're in fact using the same one on the north coast of Tasmania. I'm coming in from Victoria and Andrew's coming in from Hobart. And there are other 6-meter beacons around that are already in existence. But I do have it in mind to pursue through the Astronomical Society, and I can see Phil there listening, to whether we can host a beacon of our own somewhere along the lines of what's happening in Belgium. So in Belgium, they've got one beacon right in the middle of the country, a much smaller country, of course. And then they've got, I think, like 20 or 25 base stations, receiving stations, which they can collate the data. And there's also an interferometer receiving station, which is interesting, from which they can get direction as well. So they can correlate radio bounces with visual detection. That might be a model worth pursuing as well. But I know Rich, you're interested in the interferometry stuff, and so are we. That's another option for interferometry that we can pursue. I'll put some things on the list of, yeah. So, but I mean, basically, I've got a system working, and I know Andrew has as well. Perhaps we'll get a bit from Andrew as we go along, and there may be others. So, Rich, are we ready to go around Robin?
Go ahead. So, Mr. Board Member, you've got the floor.
Oh, yeah, I'm one step below El Presidente, Rich. So, you know.
Yeah, you don't have to be too far, and I'll let you have El Presidente anytime you want it. You know, we're very good at that.
Yes, I think a very short queue of people. Yeah, short queue of people waiting for that job. Right. So we'll do a quick whiz around the Australian members, of which we've got quite a number. And I can see Phil, and I think Mitch is there, out at LMDSS in Heathcote Dark Sky site. And Phil, I think we'll go with you first because I know you've got things to do up there. And perhaps you can run through some of the developments. We had a meeting on Monday evening, and there are developments on our dish. So, Phil, if you're happy to do so, you can give us an update on that.
Certainly. Yeah, we're at the Liaomal Radio Observatory at the moment, and there's a working bee on, hence the high vis and whatnot. The dish, as you may be aware, had our 8.5 metre dish had an issue with the worm drive for lifting and lowering of the altitude, and it started to clunk, and we went, oh dear, what's going on? Pulled it apart, and we've actually got some sample of the original worm here. I'm not sure if you can see very well or not, but there's light almost shining through there, and that was the original worm part that was lifting the dish on a lead screw, and this is a part of the lead screw, our sample, and it wore it away so much so that this now slops around on the thread. So we bandied around to find out where we could get another one made, and to get a brand new drive like this was about it was $6,000 or something, and we went, oh my god. But luckily we have a chap in our society who was an engineer who has lathes and mills and all sorts of things, and is skillful enough that he was able to purchase a phosphor bronze tube and then fashion it as a sleeve to go on the inside of this. And as you can see, he's used some what they call a Scotch lock. I don't know if you can see that, all these cap screws holding it in place. And he's was able to lathe the thread for us. And now when you put this on, there's hardly any movement at all. And it's awesome. So we're at a position now where we can start to look at reconstructing our, see there's no movement there. I'm trying to make it move about. That's really good. We're at a position now where we can start looking at putting our dish back together and hopefully get it working within another month or two. So that's our status at the moment. In the meantime, we've been working on other little projects like the Jove receiver and whatnot, but that's been our priority for quite some time.
Can I add something there too? Can I add something there too, Phil?
Yeah. Absolutely.
Yeah, thank you, Phil. That's excellent description of the refurbishment of our worm drive. But we're also concerned about weather getting into that gear. And so there's a set of bellows being constructed. We're getting bellows fabricated, which will fit either side of that worm gear on the jacking screw, so that the bellows will compress up on one side when the dish is up in one orientation, and they'll get stretched and compressed on the other side of the worm gear. So theoretically, we'll keep the weather out of that gear and we'll keep lubricating it, and we'll have a regular maintenance routine that'll give it a lot longer life. But on top of that, our friend Greg Walton, who did the machining of the worm, the refurbishment, we bought enough material, phosphor bronze material, to make 2. So when this one finally wears out, we can swap it over for another one, extend the life of the jacking system. So yeah, good times ahead, hopefully.
I'd have to
Thanks,
say I'm
Joe.
very impressed by that engineering that made that piece, Phil. I think it's very. I haven't seen it in reality, but I've only seen it on a screen. But it looks very impressive to me.
Yeah, it is quite impressive. One of the advantages he's done also is he's lengthened the actual tube. So we've got longer thread. And I don't know if you can see in here, there was I don't know if you can see it, but there's a little notch in here for the keyway. There's no keyway on the new one either. So it's full thread all the way through.
Yeah,
so
that original gear was an off-the-shelf gear, which was meant to have a plain shaft go through it and keyway lock to the shaft. But it was modified for our purposes with a thread through it, and so that keyway was redundant, really.
Yeah, I think the original one turned the actual lead screw, the whole lead screw turned, whereas ours is a stationary lead screw. But
That's
yes,
right.
all the work's been done, all the hard work's been put to place, and now all we have to do is assemble it all and get it all going again. So good times ahead. That's our report for this month. Thank you.
Phil, are you on a laptop? Are you able to swing the camera around just to show people who are not familiar with the layout there?
We see the dish in the
Oh, that's
background there, Paul.
Yeah, certainly see the dish.
And that cabinet on
Yeah.
the right is the power cabinet that's got the motor control system for the altitude and azimuth.
Yeah, that's probably as best. I can't move too much. I've got wires dangling everywhere.
Yeah.
Just that some people online may not have seen the layout.
The grass is
okay.
very green
Well,
up
that's-
there at the moment, so we've had
It
a
is.
nice, yeah.
That's a rare thing. Yeah.
We have
Yeah.
the society has a star party in September. We call it the Galactic Center Star Party because at this time of year in the Southern Hemisphere, the center of our Milky Way is right above your head at about 9 p.m. So we celebrate the Galactic Center as a star party. And so this weekend up at Heathcote, there's a bit of a working bee to spruce the place up, ready for that event.
Yeah. Well, I'm hoping that you're going to turn on clear skies for us on that night, Phil.
Well, you don't need that for radio astronomy, so
Well,
we'll be manning the
Well,
site
that's
for some
true.
Yeah, we'll be manning the site, won't we, Phil, for some demonstrations of radio astronomy, all the various experiments we've got going there. Sadly, the dish won't be operating, but we'll have a neutral hydrogen horn that we can demonstrate.
What's the dish that's in the background?
That's our radio
That's-
telescope dish, Sander. It's
Okay,
8.5 meter.
thought it was above you. Yeah, so that's the 8.5 meter dish.
Yeah,
What
that's
do you use it?
we've currently got it set up for neutral hydrogen.
Okay. What's your system temperature?
Good question. I'll get back to you on that one.
Okay.
40 degrees Celsius, Steve, isn't it?
In some.
January the 30th,
Yeah.
typically.
Yeah, and what's worrying, looking at the fires around the world, Canada and Maui and so on, they're tipping hot, dry summer for us in Australia, and possibly one of the worst fire seasons that we've had for a few years. So, and you're bang in the middle. Well, you can see the gum trees in the background there. It's very vulnerable. We just have to, fingers crossed, that
Yes, we've
the
had
fires
the
stay away.
last few years, Paul. It's there's been a lot of flooding as well in parts of Australia, so that's created a nice ground moisture, and so the grasses have grown up to about 1 metre high. So that's a nice fuel load to start things off, isn't it?
It is. Well, it's the absolute worst conditions. It's wet and the stuff grows, and then it's hot and dry, and it dries it out.
Mm.
Then wham, we're in trouble. So fingers crossed for that. Thanks, Phil. I think you've got a few things to be doing. You just head off when you need to. We might jump to Steve. Steve next. And Steve, you were talking about our Radio Jove system on Monday. I'm pretty sure we've got. Let me just check I think we've got Richard Plagg. Is that Richard? That's Richard Plagg there, is it?
Yes, it is.
Yes, it is. So, Steve, you've got Richard Plagg there, one of the originators of the Radio Jove project. So, if you've got any questions about where you're heading with that, if you want to give us a quick summary of where we are with our Radio Jove, I know you've been doing some testing, but Richard might be interested to follow where we are, and let's go from there. Over to you, Steve.
Yeah, I've got everything set up to talk about the update on the neutral hydrogen receiver. So
we can do that.
Could I do that first, and then I'll get back to you on the Jove?
Yeah, do that one
right.
first, and then the Jove. I'm just aware that Richard is with us, so that's a good opportunity.
All right. All right. Let me quickly whiz through a couple of things. The last time we talked, I presented that report on the thermal studies of the neutral hydrogen, because the redesigned receiver, the front end receiver, and I'll just bring you up to a point. One of the aspects of my report, which great, I was very pleased to see my report was published in the SARA journal. So thank you for that. This is the box of the front end, the neutral hydrogen receiver front end, which we've packaged up, and we've got a Peltier cell to cool that front end. And the Peltier cell is on a heatsink, of course, with a forced air fan cooling it. And have I shown that? Am I sharing that screen? Hang on.
Not yet.
Okay. So there we are. Yeah, sorry, I wasn't sharing. Yeah, yep. So yeah, that's the front end plastic box, and inside there is the die cast box of the receiver, and that's coupled to a Peltier cell with the heatsink and forced air cooling. And I'll just move out of that one and then go back to my report. In the report that I published. In the report I published,
Sander. I think Sander had a question.
Yeah. What's the physical temperature of the receiver? Your Peltier cooler, how cool do you?
Well, there's two aspects, Sander. The low noise amplifier is a separate box, and we're cooling that down to 5 degrees centigrade. The front end box that I just showed you in that photograph, that's going to be cooled down to 15. We're not going to be quite so ambitious to get that any colder. So there will be conditions where that temperature will drift. But we've measured the variation of the receiver gain with temperature. We're also going to have a noise reference where we can calibrate the effects of that change in temperature. So in the measurement of my report, this is a page out of my report that's been published in SARA. I pointed out that if you turn that fan off on the Peltier cell cooling heatsink, there's a sort of a thermal runaway problem. So over time, and this is a 20-minute period, the temperature of the heatsink just continues to rise. It starts off here at about 18, which was the room temperature, 18 degrees centigrade, and it continues to rise and rise and rise up to, in this case, I abandoned the experiment at 60 degrees centigrade. I was starting to worry about plastics melting. So I had to deal with that in some way. I mentioned the comment and highlighted it bold in the report that we have to deal with that and mitigate against that in some way. So I came up with this idea of a cut-off relay, so that if the fans ever stopped, you just turn the Peltier cells off. Just abandon the idea of cooling it because there's a fault, but you don't want the fault to cause a thermal runaway. So I've incorporated into the schematic of this whole front end assembly that's up on the dish this additional box, which is a thermal cut-off relay. And are you seeing that on screen?
Yep.
I think I was showing that. So
yeah, you took it away.
Yeah, I'll just bring up a photograph of that box. So what we're seeing here is the front end in that enclosure at the top. This is a power supply unit with thermostats and so forth. So yeah, I've added this other little box with a bowl of spaghetti wire going in and out of it. And that relay, it's normally closed. It's normally not connected to anything. So that the power for the Peltier cells goes through it. But there's a command control that will turn the relay on, activate the relay, and that'll disconnect the power to the Peltier cell. So it's a fail-safe mechanism, and hopefully that's going to get us out of trouble if things ever fail. Moving on to one other update that's relevant to the neutral hydrogen receiver. Our colleague who's there up at Heathcote at the moment came round during the week, and we prepared, or last weekend, sorry, and we prepared an update to this status monitor, which is monitoring the temperatures and humidity and fan speeds and all that sort of stuff. And I'll share this on screen. This is published in my report as well. This is a summary of what comes out of that status monitor. We're monitoring the power supply voltage, its current consumption, the two fans that are on the heat sinks, the fan speeds, the relative humidity of the cabinet, because this is a temperature sensor and a humidity sensor in one, and that just measures the airflow that's going through the cabinet, and that's temperature number one as well. So those two are linked as a measurement. And then the individual temperatures of the front end, that's the temperature 2 is the front end, the low noise amplifier temperature, and that temperature is the front end temperature. So this sequence of messages that comes back from the Arduino in that status monitor, it's an Arduino Nano, gets sent to a computer inside our radio laboratory, which is Phil in the background there is sitting next to our radio laboratory. And inside that laboratory is another computer that does the communication between the lab up to the Arduino up on the dish and gets those messages back. And we then process that data in a package of software that we've just recently got going. So I'll share that on the screen. And in this particular demonstration, we had it running on a Raspberry Pi 4, which is Linux operating system. We'll use our own computer in the lab. It won't be a Raspberry Pi, but it's a dedicated Linux PC running this LMRO dish device monitor version 2 software. So you can see there's a couple of windows open. The one on the top right is the Python program that collects the data and stores it in a database. The one on the bottom right, that console window, is taking that data and preparing it for a web server. And then you actually get the results out on a web server page. And this is using Firefox web browser. So we present the data as a table, an instantaneous measurement. We're only sampling, I think, was it once a minute, Philip, or is it once every 15 seconds? I've forgotten now, but I think about once a minute is enough for us. We don't need to measure it very often, but let's assume it's a measurement once a minute. And then that static number that's updated is put in the table, but it also accumulates in a graph on the left-hand side there. So that's the power supply conditions. The cabinet, as I mentioned, is a separate sensor on its own, just looking at the internals of the cabinet, but we get the opportunity to measure the ambient air that's flowing in and its humidity characteristics. Then there's a separate measurement of the low noise amplifier temperature, and hopefully we're going to have that. You can actually see some real world measurements here where it's sitting around the 5 degrees mark when it was running. And 4.9 degrees in that experiment. I ran the experiment another time later to get some samples in the screen capture for this actual this presentation now. So that was running at 4.9 degrees and monitoring that the fan is still working quite well. And the same again applies to the front end, which this is a live working measurement, 15 degrees, and the fan running as well. So that's going to be able to give us the opportunity to monitor this receiver 24 hours a day, make sure it's working. And when we're collecting data, we've got that historical record of those temperature variations. Those temperature numbers can end up in the measurement for the neutral hydrogen. So we've got a correlation between what the receiver's doing and the neutral hydrogen measurement, and we can calibrate against those problems. Thank you for that. And now I'll try and get a file together for the Jove while you discuss those results.
Thanks, Steve. Just picking up on Phil and the bit of metal work that we've had made. Rich, I think it's probably a cheaper fix than the Green Bank telescope problem that you were describing. I think we've come up slightly better than that. Any questions while Steve's just setting up the next thing? Anything on the? I think all that's going well, and it's fully reported in the SARA journal. So, thank you, Steve, for putting that in, and for
well, hopefully in the late spring, maybe early summer, we'll actually have our neutral hydrogen receiver system up and running again, and we'll start developing neutral hydrogen measurements. They're still important to us because it's the first time we would have done that as a society. And the radio astronomy section is very excited about that prospect. Joining us on the meeting this morning is Dr. Tim Davis. He's there, and he's going to help us develop the software that collects the data and processes the data, and also hopefully controls the dish. So there's like an automated process where we do scanning and measurement, rather than this manual process that we're stuck with because we don't have an automated process yet.
I know Ted Klein is waiting for your data, Steve. So I think is that right, Ted?
Always interested. Sounds good. You have a dish in Birdbath at this point. It has a coax coming down. Could you just hook it up?
There's no receiver there, though. That's the thing. There's nothing connected at the feed point.
Okay.
Yeah, it was all taken
my
down.
receiver's down on the ground, so I'm a little puzzled.
I've got the receiver front end at home at my place at the moment.
Very good. Good luck to you.
Yeah.
Great to see progress.
I've been performing all those tests on it and calibrating it, and pretty much it's finished. So I've packed it all up. There's a lot of interconnecting cables. It's a bird's nest of cables. It's all waterproof cabling, and all the boxes are waterproof. So I've packaged it all up, ready for transport up to our site at Heathcote, ready for the reinstallation.
Can you put it in place without tipping the dish?
No, we have to tip the dish horizontally and set up a scaffold at the right height, and that's tricky in itself, so that we can get the cabinet sitting over the top of the edge of the scaffold. So we've got a safe working platform. This platform's at about 5.5 meters above ground, so it's not something to be trifled with.
Oh, I agree. Okay, I'm just trying to learn the sequence of events. Right now we're waiting on mechanical, and then all kinds of things start to happen. That's great, guys. Well done.
Yeah, it's a lot of work, and but we're excited about it. We've been very methodical in the process, and I think the refurbishment of that low noise amplifier front end, the upgrade of the status monitor, all the hardware purchasing was about 1,000 Australian dollars. So it's not a trivial feat, and that's come out of my rapidly emptying pockets. All right, I'll quickly try and cover the Jove stuff now. So shared on the screen at the moment.
Question about the receiver: how do you protect it from rain?
Well,
the feed.
Those boxes, all the elements of the front end now, and there's several of them. There's a status monitor box, which is a die-cast box with an Arduino in it. There's the front end box, which is a plastic box, but inside that is the low noise amplifier in a die-cast box. The front end is in another die-cast box, which is in a plastic box. All of those boxes are waterproof. We've designed them with waterproof sealing.
Something has to come out of the box. How do you protect the feed?
How do the cables come out?
Oh, it's all coaxial, and you use butyl rubber on your connectors. You waterproof your connectors.
What about the pickup, the feed? The signal that comes into the box from the telescope, from the reflector. You have a feed, right?
Yeah, that's a feed horn. That's a standard feed horn with a Kumar choke.
How do you keep the water out of the horn?
Well, it never points vertically. It's always sort of, it's either it only ever gets hit from the side. So if water went up into it, it drops out. But we've also found the problem years ago, Sander, where a little particular native bird that lives up at that country property, I think it's a starling, is it called, Phil? The starling? They like taking mud and forming little mud nests. And we've had them around the laboratory building, but they found that the horn was a beautiful place to put a mud nest. So there was a 0.5 kilogram mud inside our cavity resonator, which had to be removed and cleaned out. So I came up with a radome idea over the front of the whole thing, which is using shade cloth. This is, a plastic nylon mesh shade cloth. So that's stopping the birds getting inside and building nests. And a lot of testing that I did found that it made no difference to the neutral hydrogen measurement. So we've protected the feed horn.
The shade cloth, what's it made of? What polymer is it?
I think it's nylon. It's UV protected nylon. I've got this same material on a fence, a barrier in my own property, and it's been sitting there in the weather for 30 years, and it shows no sign of deterioration. But I've done testing though with it, Sander. I had a transmitter at one end and this feed horn at the other with the shade cloth radome protection, and almost zero measurable attenuation with or without this material in front of the antenna at 1.4 gigahertz. So I was satisfied that it was acceptable radome material. And we've since used the dish.
I'm curious about what you're calling shade cloth.
It's a plastic woven material. It's used to stop, direct sunlight coming onto an area.
Phil's pointing to it on the
He's got some behind him, on that wall there, because we were getting direct sunlight onto the cabinet where all the power control systems are for the motors, and that's getting quite hot in that cabinet in there. So we've shade clothed the direct sunlight on the cabinet. It's a garden product, Sander.
Yeah, garden product.
Is it just a sheet of polyethylene or vinyl?
Gosh, I don't know. I think it's nylon. I think it's a UV protected nylon. Yeah.
UV protected nylon. All right, I can look for that.
Yeah, it's a very important product in Australia, Sander. We get a very strong sun. And if you want to grow vegetables, for example, you've got to have shade. It's the opposite way around to, I'm from England. In England, you want as much sun as you can. In Australia, you get too much.
Yeah, and in a garden setting, sometimes you want a nice outdoor seating arrangement. You can have a lunch or something there. It's very common in Australia to have a shade to stop direct sunlight coming in. Hence, it's called shade cloth.
It comes in different levels.
You did the loss measurement with the transmitter.
Yes.
Of course, just a little loss creates noise. That is, a quarter dB says.
Well, I'll make a proposition to you, Sander. What would you rather have? A fistful of mud inside your feed horn, or a small amount of loss?
Yeah.
These are often the fundamental decisions we've got to make.
Yeah. Practicalities.
Yes. All right. I'll quickly try and go through some Jobe stuff.
Quick Jobe, and then Andrew will go to you next.
This is the original receiver box that Phil took the Jobe receiver that's the standard NASA box and put it in this cabinet, which has a meter in the front, so we can measure the so-called antenna temperature. It's actually shown there as a scale. That's a calibrated scale, I believe. I've modified this receiver a little bit in that I've added something that we didn't have before, which was a manual tuning. We had an automatic tuning system, which would try to avoid interference. I heard the guys starting the session earlier talking about interference on Jove receivers. Well, we had the same problem in Australia, and Philip came up with a computerized tuning system so that if it got an interferer, a beat note, it would try to tune away from it. But it sort of worked, but then we didn't really know where it was tuning to. There was no calibration on its frequency. And it tended to chase its tail sometimes. Because if you have localized interferers that are inside our radio laboratory, which is evident now, there's computers in there, and this receiver sits next to all these computers. So it tends to run around and chase its tail. So we've decided to try and go back to the bare bones receiver design. And I put this potentiometer, which was part of the original Jove receiver, and just calibrated the dial. So, and you can set it to a particular frequency. Seems pretty accurate. If you tune it to 20.0 megahertz, you hear the WWV time clock. But if you tune it to exactly 20.1, there appears to be a local beat note from some sort of local interferer up there at Heathcote. So that gives you a chance to tune away from that. And it's been running for several weeks now with the receiver on the current spot, and it doesn't seem to be too bad. The other thing I was able to do was to calibrate the sensitivity of the receiver with this frequency. And yeah, so that's the assembly.
I'm confused as what it does. That is it just a signal that can be inserted into the receiver, or is it a filter of some sort? How do you?
No, that's just the original Jove receiver was a direct conversion receiver. And that's a design by NASA. We've had nothing to do with it. We just bought their kit and built the kit. And part of the kit was an analog resistor potentiometer to tune the receiver. And I've just returned it back to that original state.
Is it the frequency of the receiver?
Yes.
Receive frequency, yeah. Fine tuning.
Does it do it with a local oscillator, or is there a filter that it tunes?
There's a local oscillator, but it's a direct conversion. So your local oscillator is at 20 megahertz.
Okay.
Yeah. So what else have I done there? Yeah, so I measured the sensitivity. I was, with the signal generator into the receiver at 20.1 megahertz, I could create a scale. So with the signal generator off, the residual reading on the meter, this meter here on the left, 1.8. When it's 1.3 microvolts, this is just a carrier, unmodulated carrier from a signal generator. The reading is full scale. So when we connected it up to the antenna system at Heathcote, we're getting this background residual of about 8.5 or 9 on that scale. So that's corresponding to around about 0.7, 0.75 microvolt. So that's just a yardstick that our residual background, and it was a pretty quiet time in terms of solar and Jupiter noise, and Jupiter was over the horizon at the time. So we've got a high residual noise, and that's worse than it used to be 20 odd years ago when we first started testing with Jove. So we've got other equipment that's been installed at Heathcote. We've also got a Wi-Fi system running up there. There's lots of things that are slowly but surely building up the noise floor. We've had neighbours move in on either side of our property that seem to be there every weekend and running their trail bikes up and down and having floodlights onto their property and having barbecues. So you know the story, folks. The noise floor is getting higher and higher all the time. And what we're trying to get back to was a day when we used to see the galactic center as it went overhead. That used to be a measurable peak. That seems to be washed out now. We can't seem to get back to that residual. But we've still got a few more tricks to try. We're not done yet. One of the problems is to get away from this interference that's inside the laboratory. If I disconnect the antenna off the Jove receiver and tune that dial that I put on there, you hear beat notes. But at home in my quiet laboratory environment here in this room, I do the same thing. It's quiet. But if I switch on my PC, which I'm using now to search the web and so forth, then the monitor and all the PC noises create noises on the Jove receiver. So there's a message in that. Keep your Jove receiver away from lots of computers. All right. Thanks, Paul.
I found the same with my meteor detection system, Steve. And the biggest culprit here is LED lighting. The LED, whatever electronics are in there, they just blow the whole thing to pieces. It's and I tried getting some better LEDs, and they seem to work for a while, and then I don't know, they just seem to make even more interference. So yeah, we're really up against it, even in our remote site at Heathcote. I mean, we're theoretically a long way from city and civilization, but of course then we take our own interference generators up with us, and computers and whatever.
Yes, there's a lot of activity on astrophotography,
Yeah.
and if you look at the astrophotographic field, which is like 30 meters away from our radio
Nearby,
system
yeah.
up there, there's guys with laptops and massive computers running on a star party or a dark sky weekend all the time. So
Yes, I don't know what the answer is.
well,
but,
midweek when they're not using it, there's
Yeah,
always
true.
quiet times. You're just scheduling your observing sessions.
Yeah. But Richard Plug is with us. You're probably interested, Richard, that there's an original receiver still working away there. I know that I think they've moved to an SDR now in that design.
What,
yeah,
from
with that.
NASA.
How old is that receiver, Steve?
Well, that's the original NASA design.
Yeah.
The guy that you saw earlier sitting next to Philip, which was Mitch, he built it.
Mitch.
So
Yeah.
that goes back 20 years, doesn't it, Phil? Something close to 20. But I've done exhaustive testing on it, Paul, in my home laboratory with some good test equipment, and I think it's fine. It's a great receiver.
Yeah.
It's quite very sensitive. It's getting measurable results at 0.1 microvolt RF levels going in. And at a 20 megahertz receiver, I don't know that you need much better than that, because the environmental noise and band noise, as you would call it, is higher than the noise floor of that particular receiver.
Yeah.
So it's a good little receiver.
Yeah, very good. Well, we might jump to Andrew. And I know, Andrew, you've got Jove going there as well, I think. Do you have the same issues with picking up local interference?
Certainly do, yeah. Interference is the bane of any radio astronomer. Yeah, we'd rather be looking at something natural than something artificial, but yeah, I'll say a little bit about that. Yeah, thanks. It's great to be here too, actually, and it's great to have Richard Flagg. Richard's always inspired me in various ways over the years. I started off with AAVSO and Caspar Hosfield and various other folks along the way, but yeah, been inspired by all of the amateur work, and it's great to see the developments going on. And I'll come to talk a little bit about Jib because I'm really keen to collaborate with Steve and others there, comparing results, because there's nothing like when you're trying to sort out interference, seeing common signals,
Yes.
whether they be natural or otherwise. So yeah. So that's my setup, if you can see that picture on the screen there, hopefully. So various antennas in the backyard. So yeah, a couple of common things. I have problems with the swallows. I think you're mentioning that make mud nests. I have those on my shed there, which is where I've got my radio gear. I've got a variety of antennas out here. I've talked a little bit before. The one I'm going to just mention in the moment is my little satellite TV dish, which is now being repurposed for hydrogen. So I've started to get into that. I went back to work. I was heading for retirement, but I'm pretty full time at the moment. So I did buy a little Sawbird amplifier and filter system for the hydrogen line. Started to get that together, and I'm looking forward to making some measurements that Ted and others can use. We'll get there eventually. We'll see what I can pick up. It's a pretty small dish, but I'll say a little bit more about that in a second. that's the Yagi there, for the 6 meter meteor stuff that I do. Unlike, I guess, the Radio Joe folks that do a lot with dipoles, I've been mucking around with loop antennas for Jupiter and seeing how that's going. I do have, some dipoles up, and there's a wire going off there somewhere, and I've got some other loops and, VLF and all that sort of stuff happening. But I've been doing a fair bit with loops for Jupiter and the Sun of late, just to see how that goes. Hopefully the next slide here. So I've been having a look at the air gap patch antenna as a feed for my little dish. I was trying to actually find the reference for this article, which I might see if I can put on the chat. It's quite a nice little discussion about a variety of different feed systems. I don't know if anybody's had a experience with air gap patch antennas for hydrogen line. I haven't actually started making something, but be interested in any comments there if anybody's got a comment to share just right now. The reason I'm looking at this is that when I was doing radio astronomy for my PhD, we did quite successfully build a number of these sort of antennas for a 15-meter dish, which we use for pulsar studies. And you can do all sorts of nice things here with polarization. You can, kind of make linear or circular polarization sensitivity. So these are quite small. You can see some dimensions here on this particular setup. This is actually for hydrogen line. They're pretty compact, so it's just like basically a square plate with essentially an element on top. The SWRs for these can be quite good at the relevant frequency. So I've got a little nano VNA I'll use to tune this sort of thing up and just see if it actually works, rather than building a horn.
The copper is what distance from the back? Am I seeing it right?
Yeah, that's right. Yeah, that's the profile.
Gap?
It's around about the air gap is 7.5 millimeters.
Okay, all right.
That's the gap there.
Mm-hmm.
But yeah, the nice thing is that you can make these things fairly precise.
Mm-hmm.
And then so this one here is for 1430 megahertz. As described in this article, and as I say, I'll find the link for it because I think it's quite a nice summary of a variety of different things. So I'll give this a go and try it with my little Soulbird system. I've got, I'll probably use an AirSpy with that. But otherwise, I've been just looking at galactic noise with various Yagis and dipoles and things. But with the dish, I have done some stuff with the Sun and geosynchronous satellites and that sort of thing. Like I mentioned before, I was looking at rain attenuation from geosynchronous satellites. So that'll be the next project.
Hey, Andrew, Alex Petit has done a loop antenna and an air gap antenna like that. He's got them on YouTube videos that are Sarah YouTube channel.
Okay,
So
I'll look that up.
Just look up Alex's videos.
Right, that's a good tip. Yeah.
So, Andrew, is the backplane acting as a reflector? Is that the idea?
It's acting as a ground plane essentially.
Yeah.
That's right. So the active element's the front one.
So the air gap is then critical, presumably, to get constructive interference.
That's exactly right. Yeah.
Yep.
My quick question, Andrew, if it wasn't quite tuning, because I assume you're measuring it, if it wasn't quite on frequency, how would you trim it?
Yeah, get the tin snips out.
Okay, yeah.
Trial and error.
I think that's the idea. You make these things a little bit oversized, and you actually cut them down.
Yeah. Can't see the bandwidth on your figure there. How wide a band is it?
Yeah, so that full range there is 2 gigahertz. So they're fairly broad in here. Now it's not showing necessarily VSWR there, but
That's a return loss measurement, is it?
yeah, that's right. Yeah. So I think these things are kind of the order of a few percent, not sort of, 10%, but a few percent.
Okay.
But you can then, with the Sawbird filter, get narrower as well.
Yeah, filter it down. Yep.
So yeah, I thought that was something easy to construct. I'll give that a go, and that might actually, for other folks, it could be useful because horns are a bit of a pain, I guess, in my experience to build. I've worked with horns. I've also worked with helical antennas too, but they're not so good at these frequencies, I think. But, yeah.
What have you got there, Steve?
I was just showing Tim something. It's nothing to do with this. Just
Right. Okay. Well,
quick one for Tim. Pay attention.
Yep. Okay, Andrew. Yep.
Yeah, so meteors, yeah, look, it'd be great to have some beacons. This one that we're using, the one that Paul and I are using, actually is kind of a really good one for meteors because it is CW, except for the ident, and it's GPS locked. But it'll be great to do something around the country. And yeah, meteors are pretty interesting. So here's my summary. This is on RMOB, Radio Meteor Observers, which you can go and look up. I'm the only Southern Hemisphere site, really, consistent. There's been a few folks like in Australia or South America, but at the moment I'm kind of the only one at the moment. We had some meteor activity earlier in the month from some Southern Hemisphere showers. These are daily counts, which get displayed on this RMOB, and that's the one from just kind of now, really, almost up to date. One problem I do get is that sometimes I get some sporadic E, or I get some troposcatter of the beacon. So it's really only about 300 kilometers away. It's quite close, but I've got mountains in between. And normally for these things, you're kind of using 1,000 kilometers or so for the separation. But anyway, it seems to work okay. I am actually seeing showers. I'm seeing the diurnal variation. But yeah, I've had to cut out some stuff in here because I've just got some continuous signal. And I'm using, to do that, I'm using Spectrum Lab. There's a nice meteor detection system that the chap set up for Spectrum Lab, and it's actually quite immune to noise and other things, because one of the problems I also have is that there are aircraft flights from New Zealand to Perth, across Tasmania, that I get aircraft scatter from. There's lightning, other interference. I've got somebody locally that's using a welder, but the Spectrum Lab one is quite immune. But, when you do get interference, you actually get reduced sensitivity. So one of the difficulties in here is that some of these low counts aren't necessarily just low meteor numbers, that's just reduced sensitivity. I'm trying to work out a way of trying to keep a track of that, which the software doesn't do at the moment. But yeah, that's a bit of fun. Meteors are interesting. Seen quite some interesting things, some bolides and other things. I've got an all-sky camera that I run at the same time and an infrasound detector, so I'm interested in picking up, big bright things and things that go bang. The other week we had a Russian upper stage re-enter kind of over Victoria. A few folks might have seen that, picked it up with a camera, but also this meteor system, it produced quite a nice transient backscatter as it went over. So yeah, get to see that kind of stuff.
Came very close to Melbourne, that one.
Yeah, of course.
Sadly, it was about midnight though, so a lot of us were sleeping.
Right.
Yeah. Well, I've got work insomnia at the moment, so I was kind of right online at the time. One of the joys of working in an interesting, challenging environment at the moment. But anyway.
Yeah, well, when you first came on, Andrew, I thought you were at work in the Antarctic, looking at the picture behind you.
Yeah, well, that's where I do my stuff. Yeah, I've just put that up because I'm in the spare room, which has got all the clutter in it. So I think we'd rather look at icebergs than
Antarctica is much more interesting. Yeah, that's right.
than all the junk. Yeah, well, when there's ice there. Yeah, so I do. So yeah, being inspired by all those folks that do Sun, Jupiter, and the like, I do a bit of Jupiter, and so just noting here that I post some stuff on the Radio Astronomy Facebook page from time to time, and here's a Jupiter event back in May. Actually, Jupiter's kind of not far off conjunction. Well, a month or two after that, but still picking up stuff. I'm just generally refining my setup, and hope to make some useful observations. I guess my real interest here, actually going way back, one of my supervisors in my honours year, so that was my 4th year of uni, was Bill Ellis, who was actually a pioneer in Jupiter studies. He was amongst the early folks that looked at the S bursts and did very high resolution spectral measurements of S bursts, and I think he was kind of in the group that discovered the relationship between the frequency of the bursts and the magnetic field strength of Jupiter. So that was quite interesting. So I've kind of gone back to look at that, and but here I'm using radio sky spectrograph, which Roger was kind of using, and seeing some weak bursts there. That's with a loop antenna. That's in this IOB window. So I do keep a bit of an eye on what Jupiter's doing, but also at the moment.
Quickly, Andrew. So
Yep,
just
sure.
in that graph you're showing, what
Yep.
are the actual Jupiter bursts amongst all those other lines?
Yeah,
Fuzzy.
these little fuzzy things in here. So
Oh,
these are
okay.
S bursts.
Yep.
But you will get L bursts that will produce much, larger events spread over a wider range. But yeah, I mean, this is one of the problems, I guess, with a fixed frequency system is that, if you're around here at 21 megahertz, or actually 20 megahertz, you're down here somewhere. They can be quite transient, a bit weak compared to some of these other frequencies. This is where I find
There's a bit more energy around 22, isn't there?
Yeah, it depends on your antenna, of course, too. And I've got a loop here, which is kind of, not too bad up around this range. But they do vary in intensity. Richard will probably say some things about that. I guess the other thing is that, you can, using a spectral technique like this, it's easier to identify noise sources. So there are these sweepers going off. You've got some transient transmitters, there are all sorts of things popping up from time to time and interference. So, I've been using, fairly broadband spectral measurements to look at the bursts or try and identify them. Good thing at the moment. Yeah, sure.
Yeah, that looks very impressive. Can you say a few words about your loop antenna and the preamp?
Yeah, thanks, Richard. So it's active antenna AAA-1C. I looked that up. I look up active antenna preamplifier, and it's a chap in Europe who's built this preamplifier system, which is really versatile. And I've just followed his instructions there. It's a pretty simple loop system. It's basically just a big loop of about 1.5 meters on the side. It gives you the right inductance for his preamplifier, and it's good from baseband right up to about 60 megahertz or so. So I've actually looked at meteor scatter with the loop as well. It's good for the sun right through that band, and I've got some solar bursts on the side here in that range. The good thing about it is that you can, you can direct it to some extent. You can steer it. So I just turn it on a turnstile, and I've been trying to work out the radiation pattern. It's not too bad at low angles, which is good for me at the moment for Jupiter, which is heading north. So it's good for the northern hemisphere folks, but it's kind of 20 or 30 degrees above the horizon here, and this loop seems to have a launch angle which is around about that, and probably about 5 or so hours of right ascension in a half beam width. So it's quite broad. But still working on trying to actually get a beam pattern out of it, a measured beam pattern as opposed to a theoretical one.
Sure. That's great. I mean, we've had so many people that have had a difficulty getting a dual dipole set up in their backyard because of the size.
Yep.
And this looks very promising. I know a few other guys have tried commercial loop antennas and so far have not had much success in getting Jupiter, but they have had more success with strong solar bursts. So this looks very very encouraging.
Yeah, thanks. I was kind of looking at that because it is easier to make, basically.
That's a good thing.
And Andrew, in your spare time, are you able to document that? We could put it in the SARA journal.
Yeah, certainly. Yeah, definitely. I'm getting to a stage where I'm pretty confident with it. It's taken a while to see some bursts. I've got some other examples. I've got an example now where I was just about to mention that if you go on YouTube, of course, there's a Radio Jove system online there, K4 LED in Georgia. Great to see that because we have some common time at the moment, about 5 to 6 hours, where we both can see Jupiter. And I've actually got an example where, I've seen the same bursts that have been seen in Georgia, which is quite nice. Slightly different though, it kind of shows that there's some beaming happening. Of course, if you look in the literature, you'll find that, the beams from Jupiter are moderately narrow, perhaps, for certain bursts. So that's kind of an interesting thing.
I think it also, Andrew, your the bandwidth that you're showing shows an advantage of an SDR because you can then adjust the bandwidth. If you, as you say, if you're very narrow bandwidth, you might miss some of those fuzzy bits that you're getting. Steve, do you know what the bandwidth is of our Jove receiver?
Yeah, I brought it up before. It's actually it's only a few hundred kilohertz, so about 19.9 megahertz up to about 20.6 or something like that. So yeah, not a lot. We're stuck around that 20.1. Now, that's not something we could change it. We could look at changing the local oscillator and having another tune up a bit higher. Not going to rule that out.
Well, if you tune up higher, Jupiter will appear lower, and you won't see it. It knows.
Oh, the other way, yeah. Yeah, you got a point.
Steve, I wanted to suggest one thing. Where you have your meter calibrated in terms of microvolts, it might be nice if you have a hot noise source to calibrate it in terms of antenna temperature.
Yeah, well, it originally does have that 1,000 degrees Kelvin scale on it. Now, Philip might have a comment about that. I think we've got a calibrator. We actually, part of the Jove kit from NASA has a calibrator. So it does have that reference level, and we did calibrate that meter on a regular basis. That's a good point, and we're not going to ignore that. So yeah, we need to calibrate the system to get meaningful results, and we aim to do that as often as possible.
Yeah, that's something I'm looking on too, as a calibrator for my system. I think my system noise temperature is around about sort of 600,000 K or thereabouts, and trying to get an estimate of that. And following the Radio Jove, processes there, looking at automatic calibration, that kind of thing. Number of ways of doing
that. I think normally around 20 megahertz, the galactic background temperature is on the order of 50 kilokelvin.
Yeah.
And of course, anything much higher than that makes it more difficult to see Jupiter. And you get up above a couple 100,000 Kelvin. Here in downtown Honolulu, I've measured the background temperature at 3 megakelvin. So if anybody wants, I've got some kelvins to spare if anybody wants them.
Yeah, that's what I've got. I've got some photovoltaics and a bunch of other things around locally. Actually, this time it seems to be pretty quiet, so there's not much background, but at times I can get a lot of stuff.
It's
enjoy it if
interesting,
it's
Andrew, to
quiet.
see the sweepers go through, and some of them are at different rates. Any idea where
Yeah.
that's coming from?
Yeah, well, some of them are ionosons.
Right.
I think the slower ones tend to be ionosons, but I think a lot of the stuff's over the horizon radar
Yep.
and or things related to over the horizon radar. So there are some sounders that each of the over the horizon radars use to check, what frequencies are available. But pretty much everybody seems to have an over the horizon radar now. Australia's certainly got some powerful stuff, but yeah, there's definitely many sorts, and I've seen all sorts of strange things that can sit there for quite some time, moving very, very slowly. I have seen
As a radio astronomy frequency, it's not very well protected, is it?
No. Well, these things go through very briefly, but yeah, no, it's a pain. Yeah, so that's a bit of Jupiter stuff. So I keep doing that. I keep a lookout on things, but yeah, the sun's the other kind of interesting thing. I guess the good thing about these antennas is that they're not. They seem to be sort of circular polarized, so that helps with the Faraday rotation effect in the ionosphere. So I think the dipoles, we kind of want to get a circular polarized system going. A cup of coffee coming in. That's really good. Thanks. But yeah, these things are good because otherwise you get lots of banding in here on polarized sources that do the ionosphere. Quickly, a couple of things. I do VLF stuff. I've done that for a long time. I did AAVSO. I used to send all the charts in for that, and yeah, it was good fun. But I'm just, mainly I don't actually have. I guess a scientific, I have some scientific interest here, but I do like seeing solar flares. So here's something from yesterday. I measure phase and amplitude of a few different VLF stations, and that's all done in software using Spectrum Lab. But yeah, a little bit of solar activity at the moment was a flare yesterday. But this highlights one of the other interesting things about some of these stations that you discover when you're kind of making these phase measurements is that at the moment, these Navy transmitters, NPM, aren't exactly on, say, 21.4 kilohertz. They're slightly offset, and the offset can vary at times. And I figured it out basically by these phase steps, which occur at 0 UT each day, and it gives me a bit of an idea of the actual frequency. And in fact, yesterday there seems to be another adjustment of the frequency of NPM. We're only talking about microhertz, but it all matters when you're measuring phase. This little gap here is when they turn the transmitter off and change the frequency very, very slightly, changes the slope here. So, yeah, I'm just kind of interested in monitoring that and measuring flares. But the other thing I, of course, mentioned recently is the gamma ray burst, the greatest of all time that happened last October. So I made some measurements, and I'm working on a scientific paper about that, but I've been involved with some other folks that have used my observations. So this was at ERSI just the other day, and yeah, really honoured to be with these folks who have actually done a lot of stuff in astronomy and so on. Paul Nicholson, of course, it's a name that's probably familiar to a lot of folks that are involved in VLF, and Michael Rycroft, kind of a pioneer in the high energy astrophysics over many years. So we had that paper yesterday and the other day, and my measurements were of VLF, again measuring Northwest Cape in this case. Here's the plot I've shown before of my Northwest Cape signal during that gamma ray burst. Very strong change, a few dB in strength of that signal, sort of inverted at night time. Here's the gamma ray burst signal measured by a spacecraft around the sun, solar orbiting, and then comparing against some measurements up here by Paul Nicholson in Todd Morden daytime measurements, showing the change in signal. So in this paper, the folks have used that to look at Schumann resonance changes and other things in in the ionosphere, and got some interesting results there showing that even, you know, the Schumann resonance has changed during the gamma ray burst. So yeah, it's good when you do backyard measurements and can put them into some scientific context. So that's me done.
Excellent, Andrew. Thank you.
Microphone on. Yeah, thanks, Andrew. That's great. That's covers a lot of ground. And I think it would be interesting to have a look at that loop design and perhaps get something put out so that we can have a play with it. Now, I think, where do we go next? Roger, you had a question for that? Did you get your question sorted?
Yeah, I was actually just going to get up the software that I've got here to see if I'm just doing something wrong, basically. Actually, I've got a little bit of on the administrative stuff first. Been talking about my membership, I suppose. I haven't actually ever received an email or any information from SARA. I do believe I have actually joined, but when I was talking to Rob a couple of weeks ago, Rob Lucas, he says he's been getting all sorts of stuff and going to the looking at the conference and that sort of stuff. So I've never actually received anything. So if that's okay with you, Rich, can you see if you've got me on your books? Because I don't seem to be getting much from them.
Roger, did you get the email for this Zoom conference?
Yeah, but I get it from Paul, so it hasn't actually come from the States.
Well, all the members, all the official members get the email. So let me check you and see. We had a glitch in March that the PayPal was not accepting from the store, and I think you were right in that time frame.
Yeah, I got caught up in that. I did get caught up in that for the Super SIDS kit as well. So, and I think I redid it again not long after that. So, pretty sure I went for the membership as well. But if you could just check for us, I'll do whatever I need to get back on again. If there's been a glitch, I'll just.
All right, you guys keep talking.
I'm just not sure if I'm on there or not.
I can. I think I can check while you guys are talking. And you just went foggy on us.
You're gone.
Yeah,
camera's playing.
Yeah, it's probably my camera.
Okay,
it could be Elon. I am on Starlink. He drops out every now and then.
And I think that everybody in Australia ought to be complaining to your new Australia representative first, and then no, I'm just kidding.
There we go. I just readjusted my camera. It was probably not focusing on me. Not sitting in the right spot.
All right, Roger. I think I could find it before we even get offline here. Whether you're on the thing, and then we'll work it out.
I'm aware of the time, so we'll keep moving. Roger, you got anything to report apart from that?
Yeah, I've got a couple of things. I'm getting my Radio Jove kit happening while we've got Richard here. I wouldn't mind just getting a little bit of a comment on it. So what have we got here? So the Radio Sky. So can you all see that?
Yes.
We got it.
Okay, so at the moment, this is the first time I actually got it set up. I suppose a couple of interesting things. There's a couple of nice clear spots here. That's when my screen shut down. I was running it out in the paddock on batteries, and as soon as the screen goes off, you get these nice clear spots. So that's just something interesting. But what my questions are, I guess, is mainly about the actual package itself. Now, I'll do things here like we'll try to resize it, and it just doesn't work. So the resizing doesn't work. The bottom of if you can see down the bottom here, the bottom screen's pretty well gone, and I can't resize it enough to actually get the bottom screen to come on. I've turned I've changed the screen from
like it's frozen.
In Portugal. Now I was talking with Andrew earlier, and he said maybe try a few different line status. Sorry, I've just got a thing up. My internet connection is unstable. Unfortunately, we do have to blame Elon for that. We do have to blame Elon for that because I still think as satellites are mainly polar, going around the poles, and my view of the South Pole from here is not very good. So every now and then I lose all satellites behind a tree. So I apologise for that. Hopefully you still have me. Anyway, I could try a couple of other things here. The other thing that I'm not sure if I'm actually doing right is when I actually replay something, it'll go across the screen, and when it gets to the end, I seem to just get the first frame, which takes a couple of minutes in this case. And then when it gets to the other end, it just stops and throws up the last frame. It doesn't seem to be doing what it should be doing.
Did you do a download of a file, or was that see it as a movie?
Yeah, see it as a movie. Yes.
That's why it's looking
So
like
at the moment,
That's why it's crawling across the screen. If you just do a file download, the whole file will appear, and then you can select various time increments or time widths within it. So if you do a load data file instead of load data as movie, you'll get the whole file.
yeah, okay. So that's from the beginning to the end. So at the moment, that's only 16. I can't actually remember how long I ran it for, but yeah, I don't seem to be getting a lot. But anyway, it is showing these sweepers that we saw before, and all of this other stuff. I'm not quite sure what it is. I'm assuming it's interference, but I'll just show you a couple of others that we took a couple of weeks ago, and I'll do them as the movie file because they sort of work a bit better.
Most of the horizontal lines are just terrestrial, broadcast stations.
Yeah, and I assume what I'm showing here is when I get them on a. So this was another day, so I'm not getting anywhere near as many. But this line along the middle here seems to be here all the time. Again, getting a few more there. But see, the time jumps as soon as it gets to
Do you have
it seems to jump on the line.
Do you have a single frequency Jove receiver running at the same time?
No, at the moment I've just got the SDR running.
Okay. The reason I ask that is that the Jove receiver outputs a little bit of its own oscillator. And since that's right around 20 megahertz, you can also pick that up on other systems running at 20 megahertz.
Okay. Now I've got you guys reminded me actually, I've got probably 20 years ago, I did one of your solder together kits. And I do remember, it's got a local oscillator in it that can be, I seem to remember you could run it as an interferometer and you could take out the local oscillator on one and feed it to the other one to get it to work. But that's packed up in a cupboard at the moment, so it's not actually running.
Well, I guess that's not the answer then.
No. I'll try a couple of others of these because later in the day, in fact, quite late at night.
When things will really quiet down at night, daytime propagation, there are a lot more stations.
Yeah, so I assume again this one down here is still there at the bit under 20 megahertz. So anyway, like I say, the system itself does seem to be working. I'm not actually sure what I've got here.
3 or 4 o'clock in the morning, you may well not see any stations at all. And, around sunrise, they start to come in.
Yeah, okay. So is that the ionosphere reflecting it or something like that? So here's only a couple of little splashes here and there. This is about 10 o'clock at night.
Yeah.
But again, they've come in around that same frequency, but they're not there all the time. At the time, the solar, just keeping an eye on the solar activity for the area, it's basically zero. And at the moment, I'm only running one dipole. So it said last time I had a broken insulator. I still haven't quite got around to getting a second dipole in and working. But that's going to happen. I'm about to buy some stuff from Strictly Ham, a roll of antenna wire and some more insulators. So I probably will set one up at Wirrina. That's the Society's deep sky site, and a spare one at home here, which I might try and put on the roof. But anyway, that's so having these few little bits and pieces with the software. If I actually have a look at this, if I close this down,
I live 1 kilometre away
have
from
a-
Strictly Ham, Roger.
Oh, okay.
Yeah.
There you go. Maybe, well, their mailing thing didn't seem too bad. It was only going to be $12 or so to get it here, so it wasn't too much of a drama. Let's see if I
The
can
guy
get
who
rid of
runs the
this
shop,
panel up.
they call him Slim.
Okay, big boy is he?
Yep.
Okay, so I'm just going to try something else here.
Most
so
of my
close that
ham
window,
gear
I didn't
I
actually-
bought from him.
Yeah, okay. What do we got? Okay, so when I start Spectrograph, I get this unexpected error quitting. Comes up every time. It doesn't seem to do much. The software still works okay, but you click OK and it goes. I do actually have the receiver working at the moment. So
One thing I
seeing as
remember
this thing
about
doesn't
that,
work properly.
yeah, one thing I remember of that, Rog, is if you don't enter all your observation details in, sometimes that error might come up, like your
Right, okay.
location. Things, yeah.
Yeah, fair enough then. Okay, so when I start it, it all seems to work okay. It'll come up with.
I'm honestly having a difficult time keeping up with the software problems that we've been having. And it seems like there's a new version of the Spectrograph software very frequently, and that often introduces new errors. Larry Dodd and
Yeah,
Jim Sky
okay.
are the two experts in ferreting out what software issues are, and I'm kind of more the hardware guy.
Yeah, fair enough too. So at the moment, so I'm still getting the dipoles working. I'll probably start playing around with a few things after that, but life's getting in the way a bit at the moment.
Understand
I've
that
had
one.
one of my had one of my rental houses burned down. That's not a nice thing to happen. So they're mucking around with insurance companies. But anyway, that's all a different thing. Okay, so yeah, that's basically it. I might try and maybe work in with Paul and Andrew just to sort out a few of those things. And it does seem like there's a few other bits of software to use. The Spectrum Labs and those sorts of things. So at some stage, I'll get all that to happen. So apart from that, haven't really done an awful lot else. So probably, hopefully, next month that might happen. Hello, RS. See, keep getting all these things come up. Curtain applications. So
Things get in the
pull out
way.
all this stuff.
Well, you can do stuff via email, Roger, and then once Rich sorts out your SARA membership, there's the list of you can put comments on questions on there, and you'll always get a response.
Okay, Roger.
Yeah.
You're officially a member, but you didn't somehow end up on the email list. So I'm working that now.
Okay. That's
So
good.
that was the problem. You're not on the member in good standing list, but you should be because it says you're a paid member. So I'll see if I get
so
that
just a
working
mix
out.
up with the email.
Yeah,
Up with the
and I
email,
sent
that happens.
Check your email. I just sent you one. See if you got it. That might be the other.
Okay.
You're a member, but not of good standing. Sorry about that.
Everybody says that about me.
Now, I think, Tim, did you have anything that you wanted to? I'm aware of the time slipping by. I want to finish at 11. So, Tim, anything there?
No, that's okay. I'm just joining in to listen in to see what's happening at SARA. So I'm good. Thank you.
Yeah, lots happening. And Rob, is Rob still there? Oh yeah, Rob.
I'm still here. Basically, where I'm at is I spent three nights, online with Rich Russell and the rest of the team at the SARA conference from Greenbanks. And Rich, thank you very much for that conference. That was really, really good. For me, I'm sitting here thinking, it's really a real catch-up time. But what I've basically done is with my, scope in a box, even though it didn't come as a scope in the box, I've spent a week pointing it at the the South Pole, and I've the last week I've moved it up 10 degrees, and I'm basically learning how to process all of the data that the system generates. And it does seem to be working. I've done some processing on the files, and it seems to show up with hydrogen where the the Milky Way is supposed to be. Other than that, it's a matter of looking at Rich's interferometer work, and looking at the documentation. I see that there's references to the Sydney University stellar interferometer papers. Well, I worked on the interferometer for quite a number of times, and put the electronics together for the blue table at the interferometer, and I was really surprised to see that. But basically, it's catching up because most of my experience in the interferometry is with optical as opposed to radio. But even though things are very similar, they're quite different. So I've been looking at beam combiners, fiber to the feeds and all that kind of stuff, antenna designs, and like Roger said earlier, we spent like a couple hours out at Varuna with his Jove, and that looks promising. I may end up with something like that, as well as looking at the Fluor dish at Varuna and how to rebuild that and make that dish start to work again. I have a second set of electronics for that dish once we get it repaired and up and functional. And the other thing is, Ted has recommended that I make my 1 meter dish in my backyard, make it so it tracks objects in the sky. And I'm also working on that. I have it on an alt azimuth mount now, so I can just tweak the knobs and point it where it wants to go. Other than that, still recovering from the 3 nights of watching the conference, and like Roger said, we're off to Varuna this afternoon to do some more work on my observatory. That's about it. Questions?
Thanks, Rob.
Yeah, I'll bring down that. Yeah, sorry, I was just going to say I'll bring down a roll of the bird netting that I've got here. You can have a look at that, see if we can use that to repair the dish with. It's very, very similar sort of stuff.
Thanks.
So, I'll see you
Look forward to seeing you this afternoon.
Okay, see you then.
So I saw you online at the conference, Rob. I think you probably had greater staying power than me. The timing was atrocious. I had it running. I think I got 30 minutes past midnight was the latest I got to. Rich, I think that was your introduction and one night, and then the elections on the second night. But now the videos are going up, so everyone, the videos are, I think they're almost all there on YouTube. Make sure you subscribe to the SARA channel on YouTube, because there's stuff coming up all the time. And I'm now going to work through the papers that I missed. There's a ton of stuff there, and plenty to go at. Now, I think, is that everyone from Australia? I think we've been round at this end. So, Rich, your colleagues in America there, do you want to whiz around? I don't know who's got anything to report at your end.
Okay, Ted, you got anything?
I too am exhausted from the conference and trying to recover, and then trying to absorb it all as well. I thought it was great fun. Thanks very much again, Rich, and to Jay. Not particularly. One of those videos is me, so
that's right.
Don't miss it.
Don't miss it.
Sounds great. Thanks, guys.
And I don't know, Paul, you're a teacher. Ted's got this methodical tone that is just wonderful teaching voice. Yep. I don't know. Roger, can you put your email in a chat to me? I'm everything looks good except maybe if your email is different than what we got.
Yeah, that could. I've just checked my email. It hasn't come in yet. which is not always quite all that unusual with the system
Right.
I'm on. It can take a bit, but I'd expect it to have been here by now. So
Yeah,
yeah,
he's
I'll
got
put
the
it on the
email.
chat.
Yeah,
Just
send me
put it
the-
in the chat. Yep.
Okay. Don Latham.
Hello to everybody from Montana. I've really got nothing to report.
That was quick.
Okay. Let's see. Monroe.
Yep, I missed last month. Had some other fish I was frying, but thought I'd connect in. I'll post in the chat. There is a white dwarf that needs to be radio characterized, and so that's what I was going to try and do last month. There's a YouTube video, and I don't have to get into detail now. But if anybody has any spare cycles, and there's no particular frequency characterized at this point. But just take a look if you're curious. No, I didn't get a chance to attend the conference either. So I'll be watching it on YouTube. I've already found the first posting, so something to do there. I am starting to, for next month, observe in the very low frequency range, the sub 100 hertz level, because there's somebody out there postulating that for things that suddenly disappear in infrared and then appear in radio and then disappear in radio, their only next choice is to propagate in cosmic background gravity waves. But there's got to be a place before that that's very low frequency. And so I'm getting my SDR to do direct tuning to take a look at that. But that's it. Oh, LED lights. If one ever goes bad on you, if you got one of those smart lights, crack the thing open. You will be amazed how much electronic noise there can come out of those, aside from the fact that they use Wi-Fi. They use PWM to keep the power down. So they are flashing much faster than the human eye can perceive. And that's probably where you're getting it from. So if you get narrow width aluminum foil tape and just wrap the bottom insulator, but not so far as it comes into contact with the screw thread shell, because that'll give you a short. That's it.
Okay, and you were mentioning this white dwarf. Do you have the coordinates for that if people want to go look at it?
You can look it up in any number of catalogs. It appears in Simbad. It appears in NASA IPAC NED.
What's the name of it so they can look it up?
The actual name is, where is it here? WD 0810-353. That's the most guttural name of it. It has a 2-mass identifier and a Gaia identifier in the D2 release, and in the D3 release as well. But it looks like it's heading towards us as well. So much like things out there in deep space are all red shifted, this sucker is slightly blue shifted, so it's heading our way. But if you're really interested, like I said, I put in the chat window, there's a YouTube video you can watch. I think it's only about 18 minutes long.
Okay.
Rich, I realize we missed Joe. Joe, did you have anything from your end? It may not be there. Oh, yeah, he is.
Oh, yeah, sorry. Yes, I am here, but no, I've got nothing.
Right. Sorry, I missed you in the round robin, but
yeah, that's fine. I was blanked out. You're probably easy to...
Yeah. Thanks, Joe. Back to you, Rich.
I'm sorry, Joe. You can't have a background like that without explaining it. So sunrise?
Yeah. No, it's not. This is some stuff that Steve put up from the radio telescope before the Bering incident, and it was just a very quick series of Magellanic Cloud, I think that one is. I don't know if I can't see it.
Yes,
on that one.
it's neutral hydrogen, Rich.
It is neutral hydrogen. He put a series of readings, and I just
did a grid.
Okay.
Yep.
Joe was experimenting with Python programs, weren't you, Joe? It was something that you wanted to learn a little bit about.
Yes, yeah, that was my first attempt at using Python to do anything other than say that A is equal to 3 and X is equal to 2.
No, he took my XY data, which was measurements in a grid, just using the dish, moving the dish to a different point, taking the reading out of the neutral hydrogen receiver as a voltage, and then Joe graphed it up with a color contour, a continuous color contour, which was very good. It made it illustrative much better than I did in my hand drawing of the same image.
So Joe, you did with Steve like Ted did with me. Turn my data into something useful.
Yeah, that's good work, Joe.
I don't know about something useful. None of it's been verified, but we did get there was a picture put out by Parkes Radio Telescope, and I superimposed mine on top of that just optically and sort of faded the thing down, and it looked like there was a correlation between the published data and this little thing here. But that's as far as it's gone. The receiver's been out of commission since then, unfortunately.
Well, yeah, that's right. Okay. Helen.
Oh, hello. This seminar was great. It was good for me. It put a lot of the pieces together. We were under the bands of that hurricane, and we didn't lose power or internet. I was grateful for that. I do have one question, though. It's not really radio astronomy, but during your presentation, you mentioned that the speed of light may not be consistent in all directions. And I just thought that was just an interesting concept. And I would kind of like to research it further this weekend. And I was wondering if you can direct me to a website or where I can go just to get started, just to satisfy my curiosity and see what else I can learn.
Yeah, that's the Mon theory, MON.
Okay, 1 second. Let me write this down.
Yeah, that's the alternative to the general relativity theory.
Okay, MON theory.
Yeah, and with that
alternative to
the
general relativity.
To Einstein, it's competing with Einstein's general relativity theory.
Okay, I got that. All right.
And what that basically says is the reason we're seeing all this expansion is really because light is actually being refracted and slowed down as it goes through space instead of as a constant through space, and therefore it looks like we're expanding, but in fact it's just a trick of the light slowing down through all this refraction, and that's what they call slow light or something. So modified Newtonian dynamics. Thank you, Andrew. And put that in.
So the universe is actually 27 billion years old as well.
That's the new theory now, and that would explain how they got these giant galaxies too early in the universe, and they didn't have enough time to form. Yeah, so that's by the way, that's the new one, Helen. That we're really twice as old as we thought we were. So.
Oh, well, I really don't like that concept. But anyway, I guess this will be my recreational reading for the weekend.
It's the universe. It's not you. Okay, so don't worry about it.
Ears open, yeah.
Yeah. I'm sure you're still 28 like the rest of us. Okay.
It means I have to rewrite my lessons as well, Rich. That's unfortunate.
Yeah, that's right. This is going to mess with a lot of astronomy courses.
Yeah.
Makes a mess of a lot of physics courses as well.
Okay.
Thanks,
we'll
Helen.
get it figured out. Thank you.
Let's see. Tim Davis.
Sorry, yeah.
Tim's one of ours.
Oh, okay. Did you already talk to him?
And he said nothing to report.
No, nothing to report. I joined the ASV, the Astronomical Society of Victoria, late last year because I discovered they had a radio telescope, and unfortunately, it's been a bit broken since then. So I'm just waiting.
I've got a 9-foot dish and a Super SIDS that is broken in my backyard with a lot of antennas in the yard. So I feel it.
Yeah,
okay.
I live in a small apartment, so I can't have any antennas. I've got to borrow.
Yeah.
Okay, Bob Strickland.
Yes, I enjoyed the conference also, and I'm busily throwing up antennas here. I hope to put up a small Yagi antenna tomorrow for the H1 monitoring. I've welded up some brackets and things, so I've got things pretty much ready to mount. And I've got a couple of dipole antennas that I made, a folded dipole that I'm going to put up orthogonally and hopefully broadband monitor signals with those from about 4 megahertz up to 30 megahertz. So those should get up in the next week or two as well. So if the weather could just cool down, we have the heat going on here. So in Texas, if it could just cool just a little bit, it would help a lot. But that's about it for today.
Okay. And I think the last one is Preston.
Hi, Rich. Like others said, the conference was great, and I don't have anything to add. We just got home from our travels about 4 hours ago, so
glad to have you on.
Glad to be on. Thank you.
All right.
I think that's everyone, Rich.
Yeah, I think it is.
Very good. I was just looking at dates.
Just to say, Rich.
Yep.
Sorry. Just to say, Rich, I got your email. So whatever email address you sent that to, it did work.
Okay. All right. Okay. So there's some other things going wrong, but we'll work it out.
Yeah. Okay.
I was just looking at the date for next time, which is September 23rd. Now, I'll be an apology for that. We've got school holiday and I'm heading north. I'm heading up your way, Roger, up to Sydney and Rob. So I'll be an apology, Rich, for the next one.
But we'll still hold it. And if I send it, I guess everybody on the group will still get the notice. And by the way, same time, same station, use the same Zoom link each time, just in case you're wondering, everybody. So if you don't have to get a notice, just realize it's the same time on the 3rd, your 3rd Saturday. Yeah.
Yeah. So yeah, September 23rd.
But
and then we need. Will you compile some dates, or do you want me to do that? Because that original email runs out on that one.
Oh no, I'll just add. I'll refresh it with more dates, and we'll get more. Yeah.
Yeah. No, that's worked very well. Having the same Zoom link every time makes it very easy.
Yeah. Okay. And Roger, just check your scam email. That's probably the only other place. But all right, that's all I got. Paul, anything else?
No, that's all from me. I'm seeing my boss on Tuesday, and we'll discuss what I'm going to be doing next year as far as work is concerned. So that might free me up for some more radio astronomy.
There you go. And everybody, copy the chat, because as soon as I go offline, chat goes away, and we got the links to the conference. That's the playlist. So it's all the conference ones are under that playlist. And of course, if you go out of that playlist, you got all the videos, which are a significant number that you can always look at, including all the Drake Lounge Australia. With this will post probably tomorrow if you want to repeat it. So, okay, that's all we got. Thank you, everybody.
Thank you, everybody. Thank you.
Oh, thanks, Rich. Bye.
See you next time.
Good night.